So block break. So as we know that there are three cases: first case, second case, third case. First case, the F theta passes through the fulcrum to the center of the sliver. Second case, F theta, this left line is between the center of the drum and center of fulcrum. So F theta passes between this and these points. Third case, F theta is above this and these points. F theta is above this and these points. This is called a third case. Now coming to the problem of first problem, problem 1, example 6.21. A single block break is shown in the figure. The drum is 250 mm. The contact angle 90 degrees. Operating force is 700 Newton. Is applied at the end of the lever, and coefficient of friction 0.35. Determine the torque that may be sustained by the brake. So here this is a given figure. This is a dimension 200, 250, 50, 2 theta. F theta is acting outwards. Now here, so for the diagram, so this is the this is the 2 theta, this is the F theta. So this is the, as you can see that, so there are A, B and C. It means that this is the third case. This is the third case of the problem. So here, distance from here to here is called as the A distance, that is here it is 200. As you can see, this is 200. Distance from the force applied here to distance from center of the drum to force applied, this is called as B, that is 250 mm. As you can see, this is 250, and distance from the F theta force to center of curvature, this is called as C. So this is 50 here. As you can see, this is 50. So this is third case of operating. So now you have to find the torque applied to sustain the brake, means the force applied and the torque we have to find. So here A is 200, B is 250, C is 50. So 2 theta is 90 degrees. If 2 theta is 90 degrees, so we have to use the equivalent coefficient of friction formula. F mu equals to F mu dash equals to 4 mu sin theta upon 2 theta plus sin theta. 4 mu is the given mu into sin theta is, which is theta is 45. This is 2 theta is 90 degrees, so theta will be half of it, 45 degrees. So 2 into theta, 90 into pi by 180. 2 theta is 45. 45 into 2 is 90. 90 into pi by 180. I have to convert it to radians plus sin 2 theta. Sin 2 theta means 90 degrees. Then we get it as mu dash as 0.385. 0.385. Now, so we have to check by both ways. So towards the center and away from the center, towards the fulcrum and away from the fulcrum. So first check for clockwise rotation. F theta is away from the fulcrum. So from away from the fulcrum, so formula is, so for away from the fulcrum, the formula is 19.148. We have this formula, F theta into A upon A plus B, 1 by mu dash minus C by A. So you have to use mu dash instead of mu now, because theta is more, 2 theta is more than 90 degrees, more than 60 degrees. So now F, the applied force F is given, that is 700. F theta is unknown, 200 plus 251 by 0.385 minus C by A. So here we have F theta equals to 670 newtons. Now therefore, you know the top formula, torque MT equals to F theta into R. Therefore F theta is this much and R is radius of the drum. So we know that diameter of the drum is 250, so radius of drum will be half of it is 125, so multiply both, we get the torque applied. So this is for the one rotation, that is away from the fulcrum. Now towards the fulcrum,